Consider a one-dimensional steady heat conduction process through a solid slab of thickness 0.1 meters. The high temperature side A has a surface temperature of 80 degrees centigrade and the heat transfer rate per unit area to low temperature side B is 4.5 kilowatt per meter square. The thermal conductivity of the slab is 15 watt per meter Kelvin. The rate of entropy generation per unit area during the heat transfer process is. So we have to round off the solution to 2 decimal places and we have to find out the rate of entropy generation per unit area during this process. Let's look at the solution. We have the heat transfer rate per unit area, that is Q dot is equal to 4.5 kilowatt per meter square, and let us consider that this is the solid slab having a thickness L is equal to 0.1 meters. It has a thermal conductivity K of 15 watt per meter Kelvin. On the left hand side, let us assume that it is the high temperature side A and it is having a surface temperature of 80 degrees centigrade, which is nothing but 353 Kelvin. And on the right hand side of the slab, we have the low temperature side B. Now, from the basic governing equation of heat transfer due to conduction, we have Q is equal to Ka dt by dx, which can be written as Q is equal to Ka into Ta minus Tb by L. Now, we are given with heat transfer rate per unit area. That means capital Q by area A can be written as Q dot is equal to K by L into Ta minus Tb. Substituting Q dot as 4.5 kilowatt per meter square, which is 4.5 into 10 power 3 watt per meter square, is equal to 15 by 0.1 into 353 minus Tb. We get the surface temperature on side B as 323 Kelvin. Now, the rate of entropy generation per unit area during the heat transfer process can be estimated as S dot generation is equal to S dot B minus S dot A. That implies S dot generation is equal to Q dot by Tb minus Q dot by Ta. On the right hand side, taking Q dot as common, we have S dot generation is equal to Q dot into 1 by Tb minus 1 by Ta. Substituting all the corresponding values and simplifying, we get the rate of entropy generation per unit area during this heat transfer process as 1.18 watt per meter square Kelvin. The accepted answer range for this question is 1.12 to 1.24.